These are our distinguished panelists today, Dr. Ali Khairala from Ericsson, Dr. Ravi Madhavan from National Instruments, and Rebecca Hunter from Crown Castle. So they're going to be presenting for maybe about 5 minutes each. I want to give as much time for questions here. I've put up a shared document. I know the community can always step up and ask questions, but just to keep the presentations going, I'll leave this link up a little bit if you want to pull the browser up and post some questions. I've posted a couple of questions which the panelists are going to address as they give their presentations, but please feel free to contribute, and I think we want to make this session active. We are in that little lull of a mid-afternoon towards the end of the conference, so we'd appreciate your participation here. Without further ado, I'll introduce Dr. Ari, and let me just read the bios, because obviously these people are all so accomplished. There's no way I can just wing it. So I'll start with Ali. Ali, if you want to come, So Ali has been with Ericsson Research in various research positions, presently in Santa Clara, where he's engineering director, and earlier he was in the Research Triangle Park, North Carolina. He leads a team shaping future wireless technology and has contributed to the development of 5G, 4G, 3G, Bluetooth, mobile satellite, etc. Previously, he was faculty at University of Delaware and has received his PhD master's from University of Michigan, and he holds 100+ patents and has received the Ericsson Inventor of the Year award. So, Ali, thank you.
Okay, good afternoon. Let's see how this works. Okay, so this is a very high-level picture of where we are today. We at Ericsson, in the research side of Ericsson, started working on what's now being called 5G way back when, 5+ years ago. And now we're kind of ending 2017. We've done many test beds. We have gone full bore into standardization in the 3GPP side of standardization, and I will have a little bit more detail on that. What I want you to kind of get from this is that 5G for us is reality. This is not research anymore. So it's what I call industrializing 5G, and I have all these examples that I will not read for you. What you should note here is all the various frequency bands that we have to work at, 3.5 gigahertz, 4.5 gigahertz, 28 gigahertz in the US, 39 gigahertz in the US, and many more to come. And we are working with various allies and competitors and operators. So we work with Intel, we work with Qualcomm, we work with operators like KDDI, AT&T. The original 5G is Verizon. They are so aggressive that they are going to deploy before 5G comes out. So for us, this is now, this is reality. And industrializing, as I call it, is the key. It's very interesting to do all the early analysis and simulation and theory and test beds and all that kind of stuff. But then at some point you have to build it, and you have to build it in an industrial sense. So you have to make millions of it, and it has to last for many years sitting up on towers and whatnot. So this is not a science project anymore. This little picture here is the 28 gigahertz integrated radio that we're doing with IBM. I think it has 64 dual polarized antennas and whatnot. And a kind of very high level rule of thumb, the closer you get to the antenna, the more lead time you need. Right? So I think as you get further back into the digital world, we can piggyback onto the computer side of things, and I mean, basically, our stuff looks like computers. So then it's kind of, you don't need that much lead time. But as you get closer to the antenna, you're making RF radios and so on. It's kind of science, and it takes a long time. So moving on, what's going on the standardization side? So at some point, the companies and entities that make up 3GPP, the standards body, decided to accelerate the process. So they're working on two things. One is what they call non-standalone NR, and NR stands for new radio. So they are going to have a new radio interface, but it connects to the LTE core network. Okay, and that is, the work on that is supposed to end now. So if you are, say, a current operator and you have an LTE network, you can start deploying you know, NR as long as the equipment is there. So we are building the equipment as we're making the standard. There's another side of it, which is what they call standalone NR, which will have its own core network. Okay, so those are the two things. And again, it's only 6 months from now, or whatever, 8 months from now. Okay, so a little bit more detail on this phase one, which is what we're working on now. Something happened to the title, but don't worry about it. So it's targeting evolved mobile broadband, which is, you know, what we have in LTE, but more so, higher bit rates, lower latency, all the goodies. It's also targeting critical machine type communication, and I think I have something on that later. All kinds of frequency ranges that, like the ones you saw before. There's also the ability to connect in the standalone mode. You can connect with LTE and with NR at the same time. You can connect with 2 NR at the same time. All kinds of connectivity variations you have to do. The kind of physical layer is OFDM in phase one. People talk about other physical layers. My personal opinion is it's kind of late to introduce other physical layers because we start pushing things into accelerators and then we become inflexible. There's a lot of focus on energy efficiency and having it forward compatible for new things later, both the so-called TDD and FDD modes so that you can address all kinds of frequency spectrum. There's a lot of beamforming, massive MIMO, all the goodies that come from the communication theory, information theory side. And also from the networking side, there's network slicing. This is a bit about what we want to use it for. There's the usual stuff, which is broadband, mobile broadband, more mobile broadband. And that we're very good at, we know how to do it, but there's also other areas that we think 5G will be for. One is massive MTC, all the tiny little devices that can connect to the network and have to have very low power consumption, very long battery life, and so on. Those may not require high bit rates, of course. And then you have the other side, which is for like industrial cases, which may require extremely high reliability or low latency and so on. So then, in the end, when we build the whole thing, it has to handle all this stuff. Maybe not at the same time, but variants of it have to be able to handle all this stuff. Okay, I won't spend too much time on this. Those are different kinds of industry areas that we're interested in. The more mature ones are like vehicular, you know, all kinds of car communication, heavy industry, and so on. And there's many interactions that Ericsson is involved in. There's one specific one which comes out of our Santa Clara office, which has Ericsson, Intel, Honeywell, GE, and UC Berkeley. And the idea here is to understand what kind of processes that, you know, the kind of industry that Honeywell and GE are involved in use. And we want to understand what kind of requirements it puts on the network. UC Berkeley, the people there are interested in doing like online machine learning to try to control the processes. And of course, Intel is interested in devices and so on. So this is an example of kind of a recent sort of alliance to try to understand better an industrial case. Then finally, I would like to mention a little bit about the power program. So for us, I mean, the one thing I want you to pick up from my story is that we're in the execution phase. We're building the thing. So we're going to industrialize it, we want to deliver, we want to deploy, we want to do all this stuff for all of our lead customers like Verizon, AT&T, the Korean customers, and so on. And then, of course, all over the world. And so this phase one of the standardization is wrapping up. By December, they're supposed to have a lot of the stuff done, and by the middle of next year, all of phase one should be done. The other thing is it takes quite a long time to leverage kind of basic academic research into industrial practice. I mean, it's one thing to come up with a very brilliant idea out of academia and claim gains and so on, and we all get excited. But then it has to mature on the academic side, then it has to go into the industrial research side, then we have to put it in the system, and then we have to understand if it really gains something in that particular setup. So that takes a long time. So So which leads me to my last point, which is that I hope that power will be the platform for academia to really do some leap into the future. I hope you will not end up doing a little bit better than 5G. I'm telling you, do 10G. I don't know what that is, but so all the aspects are open, but I really hope that that you will really push the limits and that you will push us, the industry, to understand what the limits are. Because I think if you're too close to what we're doing and you think that this will please us, I think we will not have enough time to understand it and take it over. I mean, as you can see from this 5G process, everything's going slowly, and then all the money comes in, and then it accelerates. And once it accelerates, we don't pay attention anymore to what's coming from the outside. So I really think that you should pull as far ahead as possible. Thank you.
Thanks, Ali. Okay, so moving on, we have Ravi Madhavan, who's a senior program manager in the academic marketing group at National Instruments. He spent 20 years at NI working in various roles in academic relations, including enhancing engineering education by leveraging technology, collaboration with lead researchers in communications, robotics, energy, and consulting on control systems. He's received his PhD in physics from Rice University. So, Ravi.
Thank you very much, Manu. Thanks for the invitation. It's an honor and a pleasure to be here. And thanks, Ali, for leading us to 10G now. So somewhere I'm going to have to change the titles of my slides. I had 5G everywhere. So, but anyway, what you see here is an artist rendering of 5G that was about 1 or 2 years ago. So soon Ericsson base stations would be powering all this. But we need to get there. Whether it is 5G or 10G, there are some core technologies that we know are needed to, which one is it, page down? Okay, great, thank you. So there are some key technologies that are foundation for enhanced wireless communications. And you are familiar, so I'm not going to go into these, but massive MIMO, millimeter wave, multi-radio access technology, and wireless networks. And all of these are then designed to meet the standards, whether it is 5G, 6G, or 10G, which will improve spectral efficiency, which will improve throughput or latency. So all of that is needed. And what NI does is provides these components so that researchers like you can actually use this technology to build the test beds, conduct the advanced research, develop IP, develop the intellectual property and algorithms that then the companies like Ericsson can use a few years down the road, right? Well, to get there, of course, the moderator asked us to point out the trends that we have experienced. So as a company, Manu introduced me the macro trends. Not only are we experiencing these trends in communications area, but also in other areas, such as high energy physics test beds or cyber physical system test beds. So I highlighted those, and the factors that are driving these trends are usual, right? Time to market. We are always in a hurry to release come to the new standards, new performance. One of the things that we are noticing is actually people are now looking at more of not just the cost, but the total cost of ownership. So it's not just the cost of devices or the systems, but what is it going to cost me to build this test bed? What is it going to take me to maintain it, scale it, and manage the life cycle? So that is one of the other driving factors to why these trends are now becoming common in different types of test beds. And then, of course, the software. Software allows you full programmability, it gives you scalability, and so these type of trends are actually empowering, enabling researchers, and I'll walk you through one success story. We have many success stories where these common trends are being used by academic researchers like you to actually get tremendous performance from their test beds. So they are building the test beds in record time frame. They are getting tremendous performance out of those test beds, but then they are able to really focus on their research, which is what you are here to do. Not to build the components, not to spend a lot of time building test beds, but really do research on them. So we have many universities, we are involved in all of these test beds, university and industry. But I'm going to just talk about one in the interest of time, which is the Bristol University and Lund University. So a lot of information is available through various papers, journal articles, and thesis, and so on. I just extracted one slide to show you actually a simple version of their architecture. Now imagine if they were to build each of the components themselves, test them, verify them, validate them, and build this type of test bed architecture, it would take a long amount of time. By using commercial off-the-shelf components, working with a company like NI, they were able to actually put this together in a record time. They also use software-centric systems, so what that means is they were able to actually fully program and scale it. They started with a smaller MIMO test bed, but then they were able to use the same algorithms to actually scale to much larger systems because it was a software-centric system. Another component of the trend that I talked about was public-private partnership. So that's not a technology, but it is so crucial for success of these different new areas because the technology is being invented by the companies like National Instruments and our peers. And the process that it takes to put the test bed together, it is important that you involve these vendors, these companies, so that you're using the latest and greatest and state of the art. So that's just one reason. But there is also complexity here. So as you can see, we work very, very closely with Bristol and Lund from their system configuration to their architecture. We actually shared our internal libraries and source code so that they can build this test bed in an accelerated manner. Now, we won't do that every time, but when there is an important test bed like that, we will do so. We hosted the students worked with our engineers, they understood the internals of our architectures, and that actually helped them enhance the performance. So this public-private partnership is crucial, I think, for the success of the test beds. And again, not just here, but I have seen in other areas of science and technology. Okay, so in order for us to actually continue on this, we have a dedicated team in the US, and we have few people around the world. I know there are many researchers here from around the world. But as I mentioned, to be able to accomplish these type of test beds, we have to be, as companies, involved from the beginning. We learned that very heavily in our DARPA experience. We ended up actually getting ourselves involved and contributing quite a bit beyond our normal course of collaboration. And if we are involved from the beginning, which is what we like to do here, we are involved with you as an academic researcher from the beginning when you make a proposal so that you can actually properly configure a system in the proposal. We are happy to contribute that part of the proposal with you. We understand the funding processes. All these people are veterans. Actually, one of them, Kira, she's standing in the back. Kira, wave your hand, please. And she has already worked with some of you. And in fact, we have had successes in this area where these folks that I showed you, they worked with academic researchers in the process of writing funding proposals. Those proposals got funded. The research is happening, and you can see the results here. So again, we are here afterwards. So feel free to talk to us on this. Manu also asked me to comment on what NI sees as a company, what we can gain. We are part of the power, what we can gain out of the test bed. So obviously, the test beds, whether it is 5G or 10G, these are going to push the limits of use of whatever any product is designed to do. So we want to get our product used in state-of-the-art application. We want to get the validation that our products, our technology actually can be used for the state-of-the-art applications. We want the feedback. Company like NI and others, our peers, we are always investing into R&D, updating our products, new products. So we want to get feedback. We want partnerships. We talk a lot about that. But we also hope that students, particularly graduate students working on this test bed, develop proficiency in technology like NI and others. And when they go to companies like Ericsson, Nokia, and AT&T, they are already proficient, so they can hit the ground running on developing industry-grade products for these companies. And then finally, ecosystem. These test beds are not just NI. There are many, many companies, as you saw, involved. So it is a great value to NI to know that our products actually are compatible with our other vendors' products, so that end users actually are able to build these complete test beds when the compatibility is not an issue. So I'll summarize my presentation by saying research and experimentation is contributing to accelerated progress towards, I'll make that change, Ali, to 10G standards. Macro trends demonstrating successes in academia and industry. And I think NI is actively participating in this public-private partnership. Thank you very much for your attention.
Thanks, Ravi. Thanks a lot, Ravi. So next is Rebecca Hunter, who works in corporate development and strategy for Crown Castle. In that role, she looks at policy, market, and technology trends to help best position Crown Castle to utilize its assets and expertise in the evolving telecommunication landscape. Prior to Crown Castle, Rebecca has over 20 years of experience in all aspects of telecommunication network development, implementation, and operations. So Rebecca Hunter, thank you.
Good afternoon. So everybody's brain can kind of take a break because I'm the least technical person probably within a 20 square mile radius of this building. But we think we bring a very important and fundamental aspect to everything that you guys are working on. So a lot of people probably in this space haven't heard of Crown Castle before. So I wanted to just start with quickly like who we are. We are the largest shared infrastructure provider in the US, which means we have towers, small cells, fiber, and we've recently invested in an edge micro data center, so getting into edge computing, to really look at telecommunications networks from an end-to-end solution perspective. So that's where we are. So everything that, from a research perspective or putting an antenna, a sensor, a network together, we connect it. All your sensors need fiber or need something to attach to, and that's kind of where we play in this space. So we've been involved with power from the beginning, and we think this is a very crucial, important path for us because we want to be a leader. So everything we hear in a policy perspective is, a lot of times when we're in Washington or something, we're behind, right? The U.S. is not a leader in wireless research. So we think by, pulling together these at-scale platforms, it really gives us an ability to either take back that perception or really truly kind of lead some of these research and deployment. And the at-scale, I think they've mentioned it before, especially from our perspective, is incredibly important. We see a lot of infrastructure test beds from either a research perspective, a smart city perspective, transportation test beds, and a lot of times they get stuck in kind of that research level. And how, from an infrastructure perspective, can you take that at scale to a city scale is a lot more challenging than what we found anyway, than getting a test bed established. The part, I think, again, the public-private partnership, we agree is extremely important. And when we say, so it's universities, which is clear with what you guys are working on your research. And when we say government, and I know a lot of times, you might think of National Science Foundation and funding sources, but when we think of partnerships, we think of municipalities. We think of where you actually have to go and build this infrastructure. It's not just overarching policy, but literally you have to go in and get a permit to put that antenna somewhere. And we hear a lot of times a researcher has gone and said, oh, we want to put 20 cameras on the streetlight pole, and you walk into your partner city and they just look at you like, how are you going to do that? So we really think it's at all levels of government that we really need to think of that partnership, and a real true collaboration then can be had between the industry partners, the academia partners, and governments at all levels. And lastly, we see this as really the engine of growth, the engine of economic development. It's going to, transportation, public safety. It's going to solve a lot of those people problems that cities and municipalities have, and that's kind of what they look at. How can we implement things that affect people's lives and make things better for people? And that, again, from our perspective, being a foundational infrastructure company, is very important for our relationships with those municipalities, and then getting these infrastructures and these technologies that technology companies, we work with Ericsson and Nokia to attach to our infrastructure all the time. So that really is, again, going to be the driver. This is one example of where we are doing exactly what Power is proposing, at a much larger scale. So being based out of Pittsburgh, we are part of what they call the Open Edge Computing Initiative, which is out of CMU, and this is called the Living Edge Lab. It's a really small, again, 3.5 gigahertz experimental license, and really focused on edge computing. But what we've learned a lot, right? Partnering with the city of Pittsburgh, the county, CMU, and we have probably, I think at this point, about 15 industry partners from around the world that are coming in to do experiments and tests on this lab in Pittsburgh. So moving forward, so Mano said, what have we learned, right? Communication. When we start these projects, we have to communicate early, we have to communicate often. We have to be very clear on whose roles and responsibilities when you're dealing with these partnerships. Universities have certain great strengths and qualities, and then they have certain challenges, and same with industry and same with government. So really understanding where each person's plays a role in this, and how can they help accelerate the deployment and the operation, but not having that clear understanding of exactly whose role is what, and honestly who's paying for what, and who's reporting on what. How is data going to be shared or not shared? So those are all really important things that we've learned, going through our process, in particular with the LEL. So that goes back to the understanding of everybody's, strengths and weaknesses, or opportunities or challenges within their own settings. And a commitment. These are not short-term endeavors. So when we go into this, we've already been working with the OEC for almost 18 months, and we expect those three test nodes to be up by December. So it's a long-term commitment to really work on this, and then of course the research will be well into the future of that. So understanding everybody's commitment to the project is really important. And I already mentioned, how we really feel that at-scale deployments are critical to figure out how you go from a test bed to scale. And so in our space, the small cell deployment, which is 5G, 10G, hyperdensification, right now is all is the buzzword for most of the research you guys are probably working on. Will take advantage of these hyperdense networks. The need for more and more antennas and networking capability in closer and closer proximity to the end user is causing a little contention, probably between municipalities and the network infrastructure providers, and not just ourselves, but AT&T and Verizon, anybody trying to deploy this infrastructure. And there are policies, again, you really have to look at from the federal level that roll to the state, that roll to the, the municipal level, and then the other way. So it's a very complex issue. And again, the densification, when we go in and talk to municipalities, it really kind of scares them, about how much infrastructure. So when you hear you talk about all this great, really exciting technology, to a lot of mayors and governors, it's more scary than exciting right now. So we really have an obligation to help them and educate them and help them understand the end user benefits, the benefits to the constituents of what you guys are working on and what the research is really going to mean to people. And aesthetics is really one of the challenges to blend in with urban, suburban, and rural environments. And then real quick, I won't, but rural is a challenge. So how we pay for it, who pays for it, but always in our conversations about technology is, equity, right? How do we equitably get technology out to everyone, because it should benefit everyone, it should be available to everyone. But, however, it's, how do we fund it, and how do we make technology so what you guys are working on more feasible, I think it was mentioned, to make an economic model that we can really ubiquitously deploy, this, so we can reach everybody. So I think that's kind of it for me. So thank you.
Okay, thanks, Rebecca. So, so I'd like to basically open up to the floor. I think I have a question here. So the format here is, please, feel free to either use the Google document or come right up. I'd like to just take a second. I'll leave the link up here. I'd just like to take a second to summarize what's been said so far before we jump into the questions. So we've learned, at least, there's been this shift where public-private partnerships, industry, academia, partnerships are, the barriers to entry have sort of been lowered. At least the companies that are represented here, and hopefully they represent the broader view, and people can defer with this opinion. But it seems like there is sort of this shift where the partnerships and collaborations are happening. We're also seeing a movement, and I'd love to hear a little bit, I'll broach this question about collaboration between industry and academia in open source projects. So there are a lot of efforts that are being backed by different industry members and have academia as partners for sort of figuring out some of these challenges in an open source way. And that is sort of a new push that we feel that for platforms such as of the scale of Power will actually be able to leverage quite well. So I'll start with the question that I received on the Google document, and then I'll open it up to the floor. So the question for the panelists is, with network slicing coming online, could we deploy a nationwide test bed on commercial infrastructure as a network slice? So we didn't touch, I think, Ali, you mentioned a little bit about network slicing. So do you want to take this?
Yeah, I'm not sure if this thing is on. But,
Could you?
It's on.
okay. So, I mean, somebody mentioned the Genie project, and so that was kind of a lead example. I think it is more up to the operators whose spectrum you'd be using in the end, because in the end it's about spectrum, right? I mean, if you're going to use up Verizon or AT&T or whoever spectrum, you need their permission. But I think it's possible.
So at least for one of the things we heard earlier today was the FCC's program experimental licenses, which at least in the academic context, on-campus experimentation allows you to, look at spectrum that might be available.
But I think, if you want the experiment to be using commercial networks that you get the real kick, right, then they are tuned to certain frequencies, and this is where it gets difficult.
Of course. So one of the things that also came up, so you've mentioned Genie. At least Genie is an experimental facility which was funded by NSF, has a wireless edge component, but again, it's not a commercial operation. It's useful as a test bed. So we'll take questions, please.
Sure. So Mark Horner from UMass. So I had a question more about what do you think the most aggressive vision for 5G looks like in terms of, let's say, 10 years from now, I'm no longer subscribing to Comcast because I've replaced it with 5G, and all the cars have 5G, or no more Wi-Fi because it'll all be 5G inside a building. I don't know. I mean, those are my ideas. But where do you think it's going to be 10 years?
Me?
Yeah, sure.
Well, I mean, I think...
It's a hot potato.
Yeah. So, in the context what we're talking here, I think the vision is out there to some extent through the standards, but I think the vision will be realized when we have some infrastructure 5G working and applications coming up. So, things that you mentioned that I would like to do, but at the end, the vision and supported by the right infrastructure and right technology is the key. To me, maybe I'm not answering your question, but I think we still have a ways to go and various pieces to put together to get there, honestly. Rebecca, do you have a?
Well, I think, from our perspective, we do see kind of not only the traditional carriers, but obviously you have emerging tech companies that are coming at this. So the amount of infrastructure you're going to need to, and I don't know if it's all going to be from our perspective, whatever we're calling 5G. I think that's still, to some people, not necessarily the exact same definition across the board, but you're going to need a lot of infrastructure to roll out all of these new technologies, regardless of the vertical, whether it's transportation, video data analytics, public safety. And right now, I think, the problem is we don't have the densification required, that even if the technology was there today, we don't have the ability to deploy it in a way that would make it, I think, usable in a meaningful way.
Yeah, I mean, the standards are the easy part. We've been working on them for 5 years, but deployment costs a lot of money. And the density of deployment, as she just mentioned, this is the key. I mean, if you can make small cells everywhere, then you're in business. But one of the reasons why I showed these combinations of LTE and R is that it's very difficult on day one to have ubiquitous coverage, whereas you do have ubiquitous coverage for 4G. So I think if you piggyback on the 4G infrastructure and start putting 5G infrastructure, then it takes off, and then you'll have more and more of it. Then the sky's the limit.
Okay. Would it be fair to characterize this as one of the desired characteristics for power platforms to, from an experimental perspective, to see that densification so that can actually be extrapolated over time, gives the carriers, equipment vendors, companies that are on our consortium sort of the ability to make a feasibility study or a business case as it moves forward. So, I'm not trying to put words in your mouth, but is that okay? Is that a fair assessment?
Sure. I mean, I think for operators and for Crown Castle, I don't know if you will think of them as an infrastructure vendor and operator, but this is the key.
Okay.
How dense does it have to be?
Okay. So continuing we have another question on the floor. Oh, we'll actually, can I alternate between in-person and online? We are moving to VR very soon. So this is, again, continuing the theme of 5G, is do you think that academia can still contribute to shaping 5G? That's a very good question.
I think in our perspective, answer is absolutely yes. I think there are many pieces that, although Ali and mentioned Ericsson is moving forward, I think there are still many underlying pieces that need to be worked through. I think there is still improvement that could be made. The massive MIMO testbed that was built at Bristol and Lund, as far as we know, and there was actually by Facebook also, so even industry. So they are still building these testbeds and they're testing these out, and academic contribution is crucial.
I mean, just to contradict myself, what I meant is that the contributions from academia that show up in what we're calling phase one have happened.
Right.
I think if you come in today and say, no, I want to change this detail, and then we're not going to listen to you, whoever we are. So this is where I say, go far ahead of us so that then the stuff comes to us and we understand it, and I mean, it doesn't matter who introduces it, but if you come now and try to say, I have this brilliant idea, I want to introduce it into phase one of 5G, it's not going to happen.
Becca, anything to add?
Well, no. I think that we get hung up on the term 5G.
Yeah.
And, I think if we just keep talking about innovation and continued innovation and improvement, that's probably, from what I hear about and from a policy perspective, what we think about, and not necessarily kind of trying to put 5G in a box.
Okay. So this echoes what earlier was said by the keynote, which was the time horizon for at least the platforms. And again, I'm drawing this box around the new initiative that is Power, is the time scales are a little bit different. So as Ali said, industry is operating at 2 to 3 years out, but the people in this room are sort of more blue sky green field. And I think I echo back also to Shyam's Rockstar Award talk, where he sort of motivated this community to look beyond what's just happening in the industry. We'll take, Cobus, your question.
Thank you.
Maybe question for Ali, but I'll try to generalize a little bit. And I think that was in part your key takeaway, Ali, was, well, we have 5G, we're deploying it, it's a real thing. So if I can key off of that and ask the question, I mean, the way I understand it is that for power, the intent is that the industry consortium companies, you guys, will want to make use of this. And I kind of have, just from the way, and again, I'll overgeneralize here a little bit, it almost felt like your presentations were more along the line of, well, we're going to help you academics do something, which is great. I like that. But I want to ask the other question, which is, do you anticipate actually using this, the Power Platform? Or is this something where, I mean, if I just look at your first slide with the road, right, well, you had your own test beds and you were doing all those things. So is there really room for the industry consortium people to want to make use of this platform, or is this, well, we'll see what these academics do?
I think this is a very important point. What we call a test bed is something that's on the way to becoming a product, except it's very big and ugly and whatever. It is not really very flexible. So if we're making a 64 antenna test bed, we don't intend it to be n equals 64 or 128 or 1 or infinity, right? So what we call a test bed is kind of like, look, this is like a product. If you use your imagination, it will be a product. What I hope, like something like the power test bed, is something that actually is flexible and can be reconfigured and can do different things and can do things that may not make sense today, but will make sense down the road and so on. So I think, yes, there's a lot of space for having kind of more open test beds that multiple people can put multiple things. So I think it's very tricky. We call everything test beds, but they're not the same thing.
I think yes. So the answer for National Instruments is absolutely yes. We see a lot of value. I pointed out various things that NI looks forward to getting out of. I think what I understand from Ali is not as a 5G test bed, but I think again this group is saying next generation test bed, and the fact that it will be flexible so we can continue to add and evolve as the next generation standards and the vision changes, so we can test different things on it.
Okay.
Well, our perspective is slightly different. We are absolutely excited to participate. A lot of it for us is policy, like figuring out policy. How is infrastructure play? What are the needs of infrastructure? As technology changes, whether it be fiber or small cell, how do you make infrastructure co-locatable beyond what we in our industry think of co-locatable as the big, well, maybe big four carriers, but really to expand that idea. So we're really looking forward to, again, how do you densify? How do you use it?
So I think the next question that's online is actually continues this theme. So the question is 5G and millimeter wave, which is part of this, the technology, the infrastructure going to be cost effective and practical given its short range and other limitations? Is it going to be ubiquitous or just a few hotspots in a facility? So I think you've addressed some of the infrastructure challenges, and it's still an open, up in the air question. We don't have that today. But do you want to start with an opinion there?
I think that, that's some of what we're, we're trying to find out is, what's the range of some of this. It's not just millimeter wave, but, the 3.5 gigahertz, with the shared spectrum model, are they going to issue more shared spectrum, or auction more shared spectrum, from the FCC, and what are those ranges, and how, again, do you layer what you already have as the incumbent licensed carriers who are very protective of their space, and then you have to layer 3.5 and 28 and 60 gigahertz, and then what applications? So to the research point, what's the use cases for all of these different frequencies that may be very, very different, which would in turn, inform you of the densification needs for those type of uses.
Okay. Anyone wants to add to that?
No, I think just I don't know that there is any exception in the case of millimeter wave or any other technologies, and particularly the cost aspect of it, which was one of the things here. I think depending on the densification, depending on the amount of deployment, I think the cost generally for the technology goes down, and it will optimize at some point. So I don't expect that to be a barrier.
Okay.
I mean, I think in the US, the 5G is associated with millimeter wave for good reason, because the FCC has released the 28 and 39 and so on bands. But if you remember one of my slides, there were all these frequencies all over the place. And of course, we and many others are asking the FCC to also allocate lower frequencies below 6 gigahertz to this next generation wireless network. Because, you know, I mean, in the end, you're not going to beat physics. Millimeter waves have their own features, and we have to deal with them. But we will deal with them. I think if we're trying to say it doesn't work, it's one attitude. But, you know, we have the engineering knowledge to make it work.
Okay. Neil?
So I kind of cheated by asking my question both on your document.
Yes, I did see that.
Now standing up here. But my question is about the motivation. You know, we tend to do the things which worry us the most. And I'm wondering what keeps you up at night? Like, what's the biggest problem that you are worried about?
Who are you looking at?
All three of you.
All of
Yeah, go ahead.
Okay.
So you
I
bounded that in the security frame on the online version.
Yeah, so I don't want to bias your answer, but
Yeah.
What was that? I'm sorry. So did you have a context for the question specific, or?
one example would be security. Are there new security problems that you feel are going to have the potential of causing severe, you know, pain at some point?
I'm not a technical expert in that area, so I probably have to see if Ali or Rebecca has it.
I'm not a technical expert in anything, but I will from cybersecurity issues, especially when it comes to the data piece of it, the data collection piece is a huge concern. And as you look at rolling out any technology at any frequency, when you start talking about public safety or again use cases when it comes to government, municipalities, police force, voting records, there's a huge concern, and you know, how are we going to address, you know, all this data being transmitted both wirelessly and you know, over the air? How are you going to secure that? So we know it's a big issue that we hear every day from our public sector clients in particular.
I mean, I think the mobile industry, because it has been dealing closely with governments from the start, has always been very aware of security issues. I mean, security is baked in. I mean, if you look at 4G, you know, you do secure communication and so on. So I don't believe there's a special security threat just because stuff goes over the air or something, like, you know, in the public imagination that, you know, people can grab your signal, but it's all encrypted and so on. So I don't feel personally that this is what keeps us up at night.
So what does, if we were to push it, what does?
Okay, so what keeps us up at night is that, of course, is that very early on in the 5G ramp up, that it works and works well, because this will kind of determine the trajectory. I mean, you know, our early deployment. So in the US, you have these very strong operators like Verizon, AT&T, who have the strength to sort of like deploy and make it work. I mean, and they have declared that they will do that. And there's similar people and similar customers in, say, Japan and Korea and so on. So I trust that these people will, you know, go all out, because the vendors like us and Qualcomm and Intel and Huawei and Nokia and so on, we have already gone all out, you know, after 5G. So now our customers have to do the same. If they kind of put two or three sites and say, okay, it worked, great, we're not doing this anymore, then we're done for. So I think they have to kind of match us in their ambition, and they seem to be very ambitious.
So one of the things, just to make this, you know, Neil, did you have another point here? So one of the things, just to tie it back into the context of people in this room and experimentation, it seems like the industry is really pushing hard in terms of, the standards seem to be set. There's some, common agreement on what this is going to look like, and now it's the deployment trial phase that's emerging. So in that context, and again, to come back to, Kobus's point on how does industry envision using these research platforms, what might the common thread between research use and the use that industry is trying to come on? So what could a shared experience or a shared trial look like on a large-scale platform such as what we're envisioning here with Power?
My wish is for academia to do, for example, deployments that are significantly different from what an operator might do. So they might go super dense and figure out what's the good news and bad news and economic issues and all this kind of thing. I mean, because probably operators will not do that, or some application that we're not looking at, they will go after it and say, look, this is what goes on here.
Okay.
I mean, I think the way the Power Platform is, or the testbed is designed, is ability to do research, whether what Neil asked in the security area to many different areas. So I think it allows for research and exploration in many different vectors, and for next multiple generations to come, I hope, by changing the bits and pieces that need to be updated and upgraded. So I think it meets the requirements for many of the industrial partners.
Okay.
If I can mention
yes,
one thing, I mean, the spectrum sharing, we've had the two modes that we know about, licensed and unlicensed, and we have CBRS, which is still under construction. But
CBRS is 3.5.
Yeah,
just
3.5 gigahertz in the US. I think this is a very open area. I mean, regardless of what today the FCC and the industry is doing, I mean, this is an area where you can go crazy on with the research testbed.
Okay. Thiago, you get the last word.
Oh, okay. So the question I have is, so one of the interesting needs that the community has identified is this need for common tools, preferably open source, that they can access and they can modify and they can create. And there's a lot of work that's happened in Europe and US, mostly in academia, and some now recently in the SDN world, in the policy space, like ONAP and other platforms that are coming up. So that's right now happening. But one of the places where there's a critical lack of such platforms and support from industry is in the RF side, RF and the RAN piece of it. I mean, sometimes the academic efforts are very much behind. And it kind of stymies the research, interesting research that can be done, because those are many generations behind. So do you see, given that you also have a vested interest in helping kind of spur and accelerate research on this, do you see the industry, the telecom industry, getting behind and actively promoting or supporting a few critical research efforts and contributing to open source efforts to bring that open hardware, software platforms on the RAN, RF side?
I mean, I think just without being specific, the NI position we have worked with in other areas also where there is a need for open source. Generally speaking, there is an area or the layer of NI software that's not open source, but most of the IP that is built on the top of that is completely shareable. If there is a need for a specific reason or a customer, as Thiago, you're asking, would you work with a limited number? And I think we have worked with limited number of customers on opening, and one of the examples I gave was Bristol to share some of the open source. So it's, and the reason may or may not be so much for National Instruments, at least, that there is a lot of IP in what we are sharing. It's just that it generates support burden. People use it not the intended way. So in a limited way, it's always case-by-case basis. We'll consider it. We have considered it in the past. So, and we encourage the IP to be shared, and we actually provide platforms to do that.
Right.
We like to share infrastructure, so we're really happy with everything that's open, and we're agnostic. So we hope that people share and come up with some commonalities.
I mean, this is a very complicated issue, and it's not, the complicated part is not the open source. The complicated part is intellectual property. I mean, we at Ericsson have open sourced a lot of things, but not in RAN, because RAN is very heavy on IP. There's this TIP program that Facebook has pushed, and you may be aware of, and they have had, and we Ericsson are not part of it, but they have had to, committee by committee under TIP, decide whether it would be open source or it would be not open source. So it kind of reflects the complexity that I'm trying to convey. So I think this is still a very complicated issue.
Okay, well, I didn't want to close the panel on this sort of a somber note, but we are out of time. So we'll, thank you again to all our panelists, and thank you to your audience for contributing. Thank you very much. Time for a break.